Artemis II is the mission that turns NASA's new moon system from an uncrewed test into a human journey around the moon. It is not a moon landing. That detail matters. Artemis II is designed to carry 4 astronauts in the Orion spacecraft, launch them on the Space Launch System, rocket, send them beyond Earth, loop them around the moon and bring them home. Think of it as the bridge between proving the machine can fly and proving people can safely live inside it while it flies. The earlier Artemis I mission sent Orion around the moon without a crew. That test was about the rocket, the spacecraft, deep space navigation, and the return through Earth's atmosphere. Artemis II adds the most complicated system of all humans. The basic goal is simple to say, but enormous to do. The crew must ride a giant rocket into orbit, check that Orion is healthy, leave the safety of Earth, orbit travel through deep space, pass near the moon, and return at very high speed. What is known is the purpose. Artemis II is meant to test Orion's life support systems, crew displays, communication links, navigation, and the teamwork between astronauts and mission control. It is also meant to show that the spacecraft can protect people during a lunar distance journey. What remains flexible is the exact mission rhythm. Space missions are adjusted as hardware safety reviews, weather, and operations evolve. That uncertainty is not a weakness. It is how human spaceflight stays careful. Why does Artemis II fascinate people? Because it is both old and new. Humans have flown around the moon before, but this is a new spacecraft, a new rocket, and a new path toward longer lunar exploration. The takeaway is clear. Artemis II is not the return to the moon's surface. It is the rehearsal that has to work before the return can truly begin. And every moon journey begins by proving the way home. A moon mission does not begin by simply aiming a rocket at the moon. It begins with a sequence of careful steps, each one designed to narrow the unknowns before the crew commits to deep space. Artemis II starts on the launch pad with the Space Launch System, one of the most powerful rockets ever built. At liftoff, its job is not elegance, its job is force. It has to push Orion, its service module, and the upper stage away from Earth's gravity and into space. After the first violent minutes, the rocket stages fall away as planned. Orion reaches space, but the mission is still close to Earth. That early period matters because the crew and mission control can check the spacecraft before making the bigger move. This is one of the most important ideas in human spaceflight. Do not spend your biggest option until you know the spacecraft is ready. In Earth orbit, the crew can test systems, confirm navigation, check power, life support communications, and the basic behavior of Orion with people aboard. If something serious looks wrong, the mission has more choices than it would have far from Earth. If the spacecraft is ready, the upper stage sends Orion onto a path toward the moon. This burn is the commitment. It changes the mission from an orbital flight into a lunar distance journey. Then comes the long coast through space. The moon slowly becomes the destination instead of a bright object in the sky. Orion is not designed to land. It flies around the moon on a carefully planned trajectory, using gravity as part of the route that brings it back toward Earth. What is known is the broad architecture launch, check out, depart, Earth orbit, fly by the moon, return, re-enter, and splash down. What can vary are the exact timings and operational details because mission teams adjust plans around safety and performance. The memorable point is this: Artemis II is not one dramatic moment. It is a chain of decisions, and every link has to hold. That chain is what turns launch into exploration. The most important cargo on Artemis II is not equipment, it is confidence. A crewed moon mission has to prove more than whether a rocket can launch. It has to prove that a whole system can support human life, make decisions far from Earth, and survive the return from lunar distance. Orion's life support system is one of the central tests. The spacecraft must manage air temperature, pressure, and basic crew needs in a small cabin moving through deep space. On Earth, those things feel ordinary. In space, they are survival systems. Communication is another major test. The crew will not be in low Earth orbit, circling just above the planet. They will be far enough away that mission control has to operate through deep space links. Careful timing and practice procedures. Navigation also matters. Orion has to know where it is, where the moon is, and how to return spaceflight. At this scale is less like driving to a destination, and more like throwing a dart through moving gravity fields than asking it to come back home. And then there is re-entry. Returning from the moon means hitting Earth's atmosphere at tremendous speed. The spacecraft's heat shield, guidance parachutes, and recovery sequence all have to work together at the end of the mission when there is no room for improvisation. What is known is why Artemis II matters. It is meant to gather real flight experience with astronauts aboard before later missions attempt more ambitious lunar goals. What is still uncertain is exactly what engineers will learn from the flight itself. Some lessons only appear when hardware-software humans and deep space meet for real. That is why this mission carries so much weight. It is not just a trip around the moon. It is a test of trust. Trust in the rocket, the spacecraft, the teams on Earth, and the procedures that protect the crew. If Artemis II succeeds in proving that chain, it helps open the door to future missions that do more than circle the moon. First, we learn how to go safely. Then we decide how far to stay.